Claude Code is the best coding agent on Earth, and this video is about the stack I built so I don't have to send it every line of my code. One GPU, one open model, one open source harness. Everything stays on my machine, including the work no cloud model is allowed to touch. First, the honest part nobody leads with. If you go local, you lose things. You lose the smartest model on the market. You lose giant context windows, and nobody is answering support tickets for your GPU. If a video tells you local AI beats the frontier, close the tab. What local buys you is different. Privacy, a fixed cost curve, offline operation, and zero content policy sitting between you and your own machine. So who is this actually for? Developers with code they legally cannot ship to a third party. Anyone whose monthly API bill has quietly crossed the price of a used GPU. And anyone who wants an assistant that still works when the internet or the provider goes down. Hardware truth. The whole game is VRAM. My card is an RTX 4090 with 24 gigabytes. A 30 billion parameter coder quantized to 4 bits needs roughly 18 to 20 gigabytes once you add context. That fits. A 70 billion parameter model does not fit, no matter what a Reddit comment told you. If you have 12 gigabytes, you are shopping in the 14 billion class. 8 gigabytes, 7 to 8 billion. This math is boring, and it is the entire difference between 40 tokens a second and a slideshow. And you do not need a 5,000 franc battle station. A used 3090 has the same 24 gigabytes for a fraction of the price. For this workload, VRAM beats clock speed every time. By memory, not megahertz. The stack is 3 pieces. Ollama serves the model. The model is an open weights coder. I run the OpenCode family. And the harness is OpenCode, an open source coding agent that talks to any local endpoint. That's it. 3 pieces, all free, all replaceable. Install is genuinely 3 commands. Curl Ollama, pull the model, point OpenCode at localhost. No account, no API key, no usage dashboard judging you. First run, the model loads into VRAM in seconds and then stays resident. From there, every request starts instantly. No rate limits, no queue, no peak hours. 3 in the morning works exactly like noon. Now the head-to-head everyone wants. Same tasks, my local 30 billion coder against the frontier cloud model. Here is the truth. On scoped work, write this function, fix this failing test, explain this file, the local model is basically indistinguishable. On a gnarly multi-file refactor, the cloud model plans better, recovers from its own mistakes better, and needs far less babysitting. Anyone who tells you a local model beats the frontier across the board is selling a course. So I use both. Local handles the 80% of coding that is routine, and it costs me electricity. Cloud handles the 20% that is genuinely hard. My API bill dropped to a fraction, and my code stopped leaving the building by default. Where local flat-out wins. 1. Privacy. Your code never leaves the machine full stop, and that is not a settings toggle you have to trust, it is physics. 2. Cost. Electricity is the whole bill. A heavy week costs the same as a light one. 3. Offline. On a train, on a plane, during an outage, it just works. 4. No filter. The model answers questions about security research, reverse engineering, whatever your actual job requires, without a policy layer second-guessing you. 3 gotchas that eat beginners. Quantization. Take the 4-bit quant, not the 8. The quality difference is small and the VRAM difference is huge. Context. Every token of context costs VRAM 2. Around 8,000 tokens is the sweet spot on 24 gigabytes. And reasoning models. Some of them think out loud forever. Turn thinking off for structured work, or you will wait a full minute for one JSON object. Everything in this video is written up in detail. with a VRAM calculator and a model picker matched to your exact GPU at my local AI.org. Free, no sign-up. And if you want a monthly benchmark of the best local coding models, subscribe and say so in a comment. I build what gets asked for.